The question is to find out the income elasticity for the given utility function. The question is, consider a consumer with the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, where x and y are the quantities of two commodities consumed. Which of the following is true? Options are: income elasticity of demand for both the goods is equal to 1. Income elasticity of demand for good x is 0. Income elasticity of demand for good y is 0. And last option is income elasticity for good x is 0.5 and for good y it is 1. We need to find out the correct option. Okay, so we are being given the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, can be written as x raised power 1 upon 2. Okay, so this is actually our quasi linear utility function. Okay, so our endeavor is to find out the demand function for x and y. Then we can find out the income elasticities. Okay, so our endeavor is to maximize utility, which is equal to y plus x raised power 1 upon 2, subject to the budget constraint, that's price of x times units of x plus price of y times units of good y should be equal to the income of the consumer. So for optimality, we know that we equate marginal rate of substitution between good x and y, and it should be equal to the ratio of the prices. Okay, so MRS, as you know, it is MUX upon MUY. It should be equal to PX upon PY. MUX means the change in the utility due to the change in the consumption of good x. MUY means the change in the utility due to the change in the consumption of good y should be equal to price of x upon price of y. Now derivative of this function with respect to x gives us, that is the derivative of y will be 0 because we are taking partial with respect to x, so it is 0. So we get here 1 upon 2 x raised power minus 1 upon 2, the derivative of x raised power 1 upon 2 here. Okay, divided by derivative of y is 1, should be equal to px upon py. Okay, so we got here 1 divided by twice x raised power 1 upon 2. If I transpose it to the denominator, which is equal to px upon py. Okay, solve for x. So can we write it like this: 2x raised power 1 upon 2 is equal to py upon px, or x raised power 1 upon 2 is equal to py upon px times 2, or let's write it here twice, or x will be equal to transpose under root, it becomes square, so we get 4 py square divided by px square. This is the demand function for good x here. Now demand function for good y is, plug this value somewhere, or plug this value into the budget constraint, that is, so p will be equal to, so price of x times the value of x is 4 py square divided by px square. Okay, I hope I am within the limits. So okay, this stuff here, so px times x is this, plus py times y is equal to m. Solve for y, so y will be equal to, so here 1x gets cancelled, so we get 4 py square divided by px plus py times y is equal to m, or py times y is equal to m minus 4 py square divided by px, or if I write it here, y will be equal to, transpose this, it gets divided, so m divided by py times 4 py square divided by px. Okay, so this is the demand function for good y. This denotes the demand function for good x. This is actually our quasi-linear utility function. What is meant by quasi-linear utility function? I have explained it in my earlier videos. You can check it out. I don't have time and space here to show that very thing. So what is the elasticity of demand formula for good x? So elasticity of demand is the change in the consumption of good X due to the change in the income times income upon X. Okay, now if this is our demand function, its derivative with respect to income is 0 because income is not here, M is not here. That means this will be equal to 0, that is this derivative will be equal to 0. So elasticity, income elasticity of demand for good X will be equal to 0 times M upon X. So elasticity of demand for good X will be equal to 0. So let us see if we have that very option, then we can discard the other option. So elasticity of demand for good X is 0, so this option must be correct. Okay, I hope I am making myself clear.